In this learning modules, we will discuss about the medium to high pressure phases. On the basis of pressure and temperature, we can divide the medium to high pressure phases into 4 types, that is the zeolite phases, greenschist phases, amphibolite phases and granulite phases. If we will move from zeolite to granulite phases, usually the pressure and temperature increase. Zeolite phases. Rock of zeolite phases are formed by the burial metamorphism. The sediments which are deposited in a geosynclinal basin gradually subside to greater depth, where the diagenesis process for the formation of sedimentary rocks are usually occur. Before diagenesis, the lithifications, compactness, cementation also occur. When rising of temperature is more than 200 degrees centigrade, the diagenesis merge into metamorphism. The zeolite phases was first recognized by Clombs in 1954 from New Zealand, where the volcanic sands are submerged and metamorphosed at a greater depth of 20 to 30,000 feet. The lower temperature metamorphism is normally represented by zeolite phases and high pressure low temperature metamorphism by lawsonite glaucophene schist, that is also known as blue schist phases. The characteristics minerals. The important characteristics minerals for the zeolite phases are as follows: the lomentite, prehenite, pumpelite, lawsonite, albite, quartz. The typical sedimentary minerals like kaolinite and mormollinite are also present at this lower temperature. The important metabasic assemblages are as follows on the basis of Acf diagrams, that is lawsonite, lomentite, quartz, chlorite, lawsonite, lomentite, prehenite, quartz, chlorite, prehenite, quartz, calcite, chlorite and pumpelite, quartz, albite, chlorite. Prehenite, quartz, chlorite, albite and pumpelite, prehenite, quartz, albite. Let us see the Acf diagram of zeolite phases when the temperature is less than 200 degrees centigrade, that is the purely sedimentary environment. As per the diagrams, the A corner is occupied by kaolinite and F corner is occupied by magnesite and C corner is occupied by calcite. From A to C, the different minerals during sedimentary environments is your hollandite. From C to F is your calcite, dolomite and magnesite, and from tie line between A to F is your kaolinite, chlorite, magnesite. And as per the diagrams, if we will look within the diagrams, then we can find out the Montmorillonite. This is the initial Acf diagrams for purely sedimentary environments when temperature is less than 200 degrees centigrade. During zeolite facies metamorphism, the sedimentary rocks like dolomite and limestone remain as such, while the clay minerals like kaolinite, montmorillonite, hollandite, prehenite, pumpelite is also found as a clay minerals. The metamorphism starts in basic igneous rocks or grey vaccae first. Physical condition of metamorphism during zeolite facies metamorphism. The lower temperature limits is represented by the following reaction during zeolite facies metamorphism. The first reaction is the analcine plus quartz react and give rise to albite. By Campbell and Phi 1965, the second reaction is the hollandite change into lomentite plus silica plus water, and this reaction was carried out by Nice in 1968. The above reaction occur at temperature around 200 degrees centigrade. Similarly, the lomentite give rise to lawsonite plus quartz plus water when pressure is more than 3 kilobar. The lawsonite is formed, and below 3 kilobar the lomentite is formed. Prehenite is formed by the following reaction: the hollandite plus calcite give rise to prehenite plus water plus CO2. This is followed by the formation of pumpelite through the reaction 5 lomentite plus prehenite plus chlorite give rise to pumpelite plus quartz plus water. Limit of zeolite facies is recognized by the following reaction. The reaction is lawsonite plus quartz give rise to epitote geosites plus pyrophyllite plus water. The reaction is carried out by Crawford et al. In 1965. Similarly, the pumpelite plus chlorite plus quartz give rise to clinogeosites plus actinolite plus water. Pumpelite plus quartz give rise to prehenite plus clinogeosites plus chlorite plus water. Next reaction is prehenite plus chlorite plus quartz give rise to clinogeosites plus actinolite plus water. The next important reaction is kaolinite change into pyrophyllite, and that indicates the beginning of green cis facies. The reaction is as follows: the kaolinite plus quartz give rise to pyrophyllite plus water at 345 degrees centigrade 2 kilobar, 375 degrees centigrade 4 kilobar by Thomson 1970. The pressure limit. the lower pressure limit and higher pressure limit during zeolite phases. The pressure limit, thus the disappearance of kaolinite, hollandite, prehnite, pumpelite, montmorillonite, analcime indicates the beginning of the green schist phases. And on the basis of different reactions, we can say the upper pressure limit during zeolite phases metamorphism can be recognized by the following reactions. The albite change into zeolite plus quartz at 200 degrees centigrade 7.5 kilobar, 300 degrees centigrade 9.5 kilobar by Newton and Smith in 1967. Second reaction is calcite change into aragonite at 180 degrees centigrade 5 kilobar, 300 degrees centigrade 7 kilobar, 400 degrees centigrade 9 kilobar by Crawford in 1972. Other reaction is chlorite plus albite give rise to glaucophene plus water at 200 degrees centigrade 5 kilobar, 350 degrees centigrade 7 kilobar by Rover in 1972. Thus, on the basis of the following reactions, we can say the temperature limit for zeolite phases varies from more than 200 degrees centigrade to 400 degrees centigrade, and pressure limit is nearly 8 kilobar, that is varies from 4 to 8 kilobar. Try to see the Acf diagrams of zeolite phases on the screen. When temperature is less than 200 degrees centigrade, we can see the following assemblages like kaolinite, hollandite, calcite, dolomite, magnesite, chlorite, montmorillonite, plus minus quartz and plus minus analcime. The first important change during metamorphism is the formation of lawsonite and lomentite by the breakdown of hollandite. Hollandite give rise to lawsonite oblique lomentite. When pressure is more than 3 kilobar, the lawsonite is formed, while the pressure is less than 3 kilobar, the lomentite is formed. Now we can see the change of the Acf diagrams. As per the new diagrams, after this reaction is kaolinite, lawsonite, lomentite, calcite, dolomite, magnesite, chlorite and montmorillonite. Now further, the analcime change into albite and formation of prehnite. The prehnite is formed by the reaction between hollandite and calcite, and hollandite and calcite give rise to prehnite on the same tie line of A and C. Later on, the formation of pumpelite. The pumpelite is formed by the reaction of lawsonite, prehnite, chlorite and give rise to pumpelite. Similarly, the disappearance of all clay minerals like kaolinite, montmorillonite lawsonite lamontite, prehenite pumpelite, and the final Acf diagrams that also indicates the beginning of greenschist facies. The upper limit of your zeolite facies and the beginning of your greenschist facies, that is, as per the diagram, the A corner is occupied by pyrophyllite, C is by calcite, and similarly the magnesite, tremolite, actinolite, dolomite, and epidote and chlorite. So that indicates the beginning of your greenschist facies. So on the basis of different reactions, we can derive how the sedimentary environment or clay minerals finally change into greenschist facies assemblages, and whatever reactions is there, all reactions are dehydration reactions. It means rock is slightly dry during metamorphism, or in other words, the release of water during reactions.